Tina's Maths. I teach CBSE 10 Maths. This is my sister Tina Lovers. She teaches 8 Maths. Alright, now let's jump into the Today we are going to be learning chapter 10 Circles. In this chapter Circles, we are going to be solving theorem 10.1. So this is really an important theorem. So in this theorem we are going to be writing the statement, given values, construction and what we are supposed to prove, and of course the proof. Okay, so now let us solve it. Okay, first of all we are going to be writing the statement. So the statement for theorem 10.1 is, so this is the statement. So the statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so it is somewhat tricky, I know. So this is the first video in this chapter Circles. So I haven't explained what is a tangent, so now I'm going to be explaining it. Okay, so for example, this chapter is all about circles, am I right? So if it is all about circles, then the theorem is also based on circles, am I right? So there is a circle. Okay, so in this theorem also we have circle. So this is the circle. So in this circle, what is the tangent? So one second, let me just draw a line. So that is going to be the tangent. Okay, so not only for this circle, for all the circles, no, that is going to be the tangent. Okay, so this is a circle, am I right? So for this circle, so the line which is touching the circle like this, so this is known as tangent. Okay, so remember this is known as tangent. The line which is touching the circle like this, it is known as tangent. So you guys might be wondering that why can't it touch some other side? So can't it be this side, here, or this side? Okay, so that is also known as tangent. If the same line is here like this, then it is also a tangent. If a line is touching the circle here, then that is also a tangent. Okay, so no matter what, wherever the line is touching, that is known as tangent. Okay, it should touch like this. Okay, so this theorem is about tangent. First of all, we are supposed to understand by this statement. Okay, so the tangent at any point of a circle. So here we just took a tangent, that is this line at any point of a circle is perpendicular to the radius. Okay, so of course you guys know what is the radius. Okay, first of all, if we draw a circle, it should have a point, am I right? That means that point, it should have a point. We can just name it as O. Okay, so this point is known as O. Okay, so according to the circle, what is the radius? Radius means this is a radius. So here it is a radius. This is also considered as radius. This is also a radius. This is also radius. Everything is radius. Am I right? So we can just take any one radius. Okay, so I'm going to be taking this one. Okay, so one second. So for this circle, I'm going to be taking this one as radius. Okay, so we can just take anything, but it should be a radius. Okay, so this is a radius of this circle. So so here according to the theorem 10.1, here the tangent at any point of a circle, so this is a tangent, is perpendicular to the radius. So perpendicular means which is having 90 degree, right? So we just denote it by this symbol, am I right? So this is known as perpendicular. So so this radius should be perpendicular to the tangent. So what is the tangent? So sorry, the at any point of circle is perpendicular to the radius. Okay, so the tangent is perpendicular to the radius. So this is known as tangent, this line is known as tangent, and this is known as radius, am I right? So it should be perpendicular. So perpendicular symbol is represented as 90 degree, am I right? So you can just represent it like that. So it is a 90 degree. Okay, so I hope it's not visible. So one second. So it is 90 degree. Okay, so here this point is known as or denoted as O. Okay, so we can just name the tangent also, that is x and y. Okay, so here this is x and this is y, and here this is a radius, so radius O, and here this is P. Okay, So you guys might be wondering, so this tangent of any point of a circle is perpendicular to the radius, am I right? So it is perpendicular to the radius through the point of contact. So what is this point of contact? Okay, so please note on this. This is really important. So you guys might be wondering, what is this point of contact? So point of contact is nothing but, here we have one point, am I right? So this is a radius. Of course you guys know this is a, so once again, so this is a radius, am I right? So for this radius is meeting at a point, am I right? So that is this point. So this point is denoted as letter P. So this is the point of contact. Okay, so it is contacting. So it is just meeting at a point, am I right? So this is known as the point of contact. Okay, so again let me just explain it. So there is a tangent in a circle, so which is perpendicular to the radius. Okay, that's why we denoted with this symbol. Okay, so this symbol. Okay, so I guess it's not visible, so it is denoted as this symbol. Okay, so like this I just denoted it. Okay, so what is the radius? Radius OP. Okay, so the tangent of a circle is perpendicular to the radius through the point of contact. So that is P. Okay, so P is the point of contact. By this point of contact only it is perpendicular. Okay, so now you guys might be wondering, what are the given things? Of course in a theorem we are supposed to write the given things, am I right? So 1 second, I'll just explain it properly. Okay, so now let us write given value. Okay, I mean given things. So let us write given. So what are the things given in this figure? So by looking at the figure itself we can understand. Okay, so there is a circle. Okay, so no need to write that there is a circle and all, that is for your understanding. Okay, so there is a circle, of course there is a circle. So that circle is having a center O, am I right? So we can just write a circle with center O, which is having xy as tangent. This is the tangent, that is this line. So this line is xy, am I right? So xy is a tangent at the center, at the point of contact P. Okay, so first of all let me just write it, then you will understand. Okay, so first of all now we can just write a circle with center O. Okay, so circle, it is having a center, that is O. So in this xy is a tangent. Okay, so xy is a tangent. Alright, so xy is a tangent at a point of contact. At a point, okay, I'm sorry, at a point of contact. So since you guys know what is contact, point of contact, am I right? So no need to explain it. Okay, so we just wrote the given things. So according to this figure, by looking at the figure only you can just write the given things. Okay, so there is a circle which is having a center O. So this is the center, that is O, and there is a tangent, am I right? So we just drew these things by using the statement. Okay, so from statement itself we just found most of the clues, am I right? Of course we just found it by using the statement. You are supposed to learn each and every single line. Okay, so it is really important, this theorem. Of course it's really important. Okay, so please learn this theorem. So there is a tangent, that is xy. Okay, of course there is a tangent, it is xy at a point of contact P. Okay, so P is really important here. So at a point of contact. Okay, so this tangent is at a point of contact. So this is that point, that is contact. Okay, so this xy is lying in the at the point of contact. Okay, so it is just lying in this contact place. So now what we can just do is we can just write the next, we can just move ahead. Okay, so then what is the next step? So of course in a theorem we are supposed to write the statement and the given things, and of course we are supposed to write the construction and what are we supposed to prove, am I right? So now let us write what are we supposed to prove. Okay, so since you guys know we are supposed to prove, am I right? So prove means we are supposed to prove it. yeah, it's somewhat complicated, so don't worry, I'll explain it. Okay, so if there is a theorem, we are supposed to prove something, am I right? So whether this is equal to that one, or we are supposed to prove that triangle ABC is similar to triangle BDE, so like that and all. We have some we are supposed to prove something. Okay, so likewise in the circle lesson also, in this theorem 10.1 also, we are supposed to prove. Okay, so if we don't have anything to prove, means no need of this theorem, am I right? So if there is a theorem, then we are supposed to have something to prove. Okay, so what is that something to prove? So according to this theorem 10.1, we are supposed to prove this OP is perpendicular to XY. Okay, so this OP is a radius, am I right? So this radius should be perpendicular to XY, that is the tangent. So that one we are supposed to prove. Okay, so since you guys know OP is perpendicular to XY, that one we are supposed to prove it. So since you guys know we are supposed to prove that, we shall just write that one. Okay, so we shall write OP. So I guess it's visible. Alright, so we are supposed to write OP perpendicular to XY. So we are supposed to prove this. Okay, so we are supposed to prove it. Okay, so now since you guys know we are supposed to prove OP, that OP is perpendicular XY. So after this step, we are supposed to write construction. What are all things we did after drawing a circle? Okay, so first of all, now we can just write construction. So if you just write all these steps, then only you will get the mark. Okay, then only you will be able to score mark. So construction. So what is the construction? Construction means after drawing the circle, we just did few things, am I right? So we are supposed to do that. Okay, so first of all, I'm going to be doing the same circle, that is this circle. I'm going to be drawing the same circle in another page. Okay, then only it will be easy for you guys. So now let me just do that. So now let me just draw a circle. So there is a circle. So this is a circle. Okay, so from this circle we just did few things at the starting, am I right? So we are going to be doing the same thing. Alright, so there is a circle. So this circle is having a tangent, am I right? So we are supposed to draw this tangent. Okay, so we are supposed to mention everything in the construction. Okay, so according to the statement, the circle is having a tangent, so we can just draw the tangent. So one second. Okay, so this is a tangent, so that is X. Let me just do it with this one. Okay, so that is X and Y, and it is having a center point, that is O, and then there is a radius which is meeting at a point of contact, that is P. Okay, so these are the stuffs we did it, am I right? So what are we supposed to write in this construction? So here we are going to be doing extra work right over here. Okay, then only we will be able to prove AOP is perpendicular to XY. Okay, so now this is the main structure. According to the statement, we just drew all those things. Am I right? It is mentioned in the statement. So until here, whatever we just did, no, we are not supposed to mention in the construction. Okay, so further what are we gonna do in the circle? No, that one we are supposed to mention. Okay, so now since you guys know we are supposed to prove OP is perpendicular to XY, that means this is OP which is perpendicular XY. So since we have to prove it, so we are supposed to draw another one line. Okay, so let me just do it. So we are supposed to draw another one line like this. Okay, so we can just name it as R and here it is Q. Okay, so you guys might be wondering, why did I do it? For what reason? Is there any reason to do? Why are we supposed to do it? So I'll explain it. Okay, so just because we want to prove that OP is perpendicular XY, we are supposed to draw this line. Okay, then only we'll be able to conclude, right? So remember this. Okay, remember this one till the end of your life. This is really important. Okay, so if you want to prove something is perpendicular, that is this one. Okay, so something is perpendicular to something else, that means something else means some other line. If you want to prove it, then we are supposed to make the perpendicular line the smallest side. Okay, so I know it is difficult. Okay, I'll explain. Okay, so here this is a perpendicular line, of course you guys know. So we just drew extra line so that this perpendicular line should be smallest one. Okay, so if this perpendicular line is shortest one, then it is a according to the theorem 10.1 we just proved it. Okay, if it is not the shortest one, then the what we did is wrong one. Okay, so that is the main structure of this theorem. Okay, so we are supposed to prove that this is perpendicular. If we want to prove this is perpendicular, then it has to be the smallest side or shortest side. Okay, compared to this line. Okay, so compared to this line, this should be shortest one. Okay, so we are supposed to prove it. So what can we write in the construction? So in construction we can just write join OP and OQ. Okay, I'll explain this, don't worry. OP and OQ. Okay, so you guys might be wondering why, so don't worry. So we just joined extra point, am I right? So we just joined OP and OQ. Okay, so OP is already there, but this is a new one, right? So recently we just did it. Okay, after this step only we just drew this line. That's why we just wrote this one, OP. Okay, so nothing will happen if we write it. Okay, so join OP and OQ. So we just joined it. So why did we take this line? Just because to prove that OP is perpendicular to XY. Okay, so that is a simple reason. Alright, since we did the construction, now we shall get into proof. So if you want to prove something, we are supposed to show the proof. Am I right? So likewise, now we shall just show the proof so that this theorem is correct. I mean OP is perpendicular to XY. Okay, so now we can just write proof. Okay, so we are supposed to prove it. Okay, so first of all, now let us write choose any point Q. Okay, so we are supposed to choose any point that is Q on the tangent XY. Okay, so first of all let me just write it. Okay, so when I just dictate it, no, it will be somewhat like confusing. So first of all I'll write it and then I'll explain it. Okay, so choose any point. So any point we can just take it, that is Q. Okay, we can just take Q at tangent XY. Okay, so according to what does it mean? Okay, according to it, so choose any point Q. Okay, so we are supposed to choose any point that is Q. Okay, we are just taking Q at tangent XY. So in this XY line, no, we are supposed to choose a point. So here we are just choosing Q. Why? Because then only it will be easy to prove it. Okay, so we are just taking the Q point. So now what are we supposed to write ahead? So we are supposed to write OQ, the line OQ. Okay, so the line touches the circle. I'll explain it, don't worry. Touches the circle at circle at R. Okay, alright, so what does it mean? So there is a line OQ. So now let us search the OQ. So in this circle we have OQ here. Okay, so this is OQ. It is touching the circle at R. What does it mean? So for example, so there is a circle, am I right? So there is a circle and there is a tangent. Okay, so according to this tangent, here it is X and Y. Okay, so there is a radius. So this is a radius and it is meeting at a point of coordinate, that is P, and then it is meeting here, and here it is Q, and here it is R, and here it is O. Okay, so here the line OQ touches the circle. So what is that OQ? So this is that OQ which is touching the circle at R. Okay, so this is the exact circle, am I right? So this is just a line, that is tangent line. Okay, so here I have a question for you guys. This is a general question, you can just answer it, okay. So here we have Q, am I right? So the question is this Q is touching the circle or what? Yeah, it is touching the circle, am I right? So it is touching the circle at R, am I right? So this is what we mentioned in this. So this Q, that means OQ, the O is also touching the R, the Q is also touching the R. So like this they are coming and they are touching, and like this they are coming and they are touching and they are meeting at a point R. Okay, so this is the exact definition. So they are just meeting at a point, that is R. Okay, so we just mentioned that the line OQ, it is meeting at a point R. Okay, so that means it is touching at the touching the circle at R. Okay, so here this is not in a circle. The Q, I have another question. So is the Q in the is in the circle place or in the tangent place? So the Q is situated in this line, am I right? So this is that line, that is a tangent. So it is situated in the tangent place, it is not at all touching this circle, am I right? So in case if we don't have this ornaments, it won't touch the circle, am I right? Just because we had this ornament, it is touching the circle. Because of this, it's going to be a great useful for us. Okay, it's going to be a big advantage for us. Okay, so you will just understand it when we'll move ahead. Okay, so here this O is touching the R and Q is also touching the R. That's why they mentioned the line OQ touches the circle at R. Okay, so it is touching the circle at R. Okay, after writing this, now after I just explained it, am I right? So after doing this, now what we can just do is we can just write OR is smaller to OQ. I'll explain it why. Okay, so now we can write, so this is a condition. Okay, so OR is smaller to OQ. So where is it OR? So this is the OR, so which is smaller to OQ. So we have OR right over here and we have OQ right over here. Okay, so what is the distance between OR and OQ? What is the differentiate between them? So here we have a certain distance, that is OR. Okay, so this is smaller, am I right? So this is smaller and here this is bigger. Okay, so this portion. Okay, so for example, so don't look at these things in. Okay, so there is a line. Okay, so in this I have a question for you guys. So here OR and OQ Q. Okay, so in this, which is the smallest one? Okay, I'll mark it like this also. Okay, so in this, which one is the smallest part and the largest part? Okay, so whether it is OR or OQ, whether it is OR or OQ. So according to me, OR is the smallest part and here OQ is the biggest part. I mean biggest side. Okay, I'm sorry for using the word part. Okay, so that is not correct for this one. So side is the correct one. So this is the OR. So OR is the smallest part and OQ is the biggest part. Am I right? So we are just taking the everything. So OQ means it is including the OR as well. Am I right? So that's why OQ is the biggest part and so let me just write OR is the smallest part, small, and OQ is the biggest one. So you guys might be wondering how I don't even understand. Don't worry, I'll explain it. So for example, here we have O or Q, am I right? So here, according to your conclusion, which is the smallest part and which is the longest part? Only the line. Okay, so not including other lines, only this line, focus only on this line. So according to this line, so if you want, let me just highlight it. Okay, so for example, this part. Okay, I am just mentioning this part. So according to this part, which one is the longest one and which one is the shortest one? So OR is longest, OQ is longest. So which is the longest? For example, here also we have the same, we are just mentioning the same line. So here This is the longest water. This whole thing is the longest water. So according to me, OR is the longest. I'm sorry, OR is the shortest. Okay. So once again, so this is shortest and this is big. Am I right? So see the bracket right over here. So this one is little bit small, but this is so big. Am I right? That means this is the biggest one. So this whole part is the biggest portion, but this part is the smallest portion. Am I right? So okay, I'll explain. I'll show it like this. So OR is smaller, OQ is small. So see the difference in the fingers. Okay. So OR is small and OQ is big. Am I right? So small, big, small, big. Okay. So this is small and this is big. Okay. So this only I just mentioned it. Okay. So that is OR is smaller to OQ. Why is it smaller to OQ? That's because we can just write, therefore OP is equal to OR. Okay, OR. Okay, so you guys might be wondering what does it mean. So OP, so this is OP and OR. Am I right? So OP is equal to OR. I mean, of course it is equal to OR. So you guys might be wondering how it is equal to OR. So here we have OP and here we have OR. Okay, so both are the radius. Am I right? So both of them are the radius. So this one is a radius. So this one is a radius and this one is also a radius. Okay, so we are not mentioning Q. Why? Because the Q is out of the circle. Okay, so this portion, it is out of the circle. This line is out of the circle. Only this line, that means O to R and O to P. This is the line which is inside the circle. Okay, so that's why we just wrote it like that. Okay, so we just wrote it, and now we can just conclude that OP is smaller to OQ. Okay, so if OR is smaller to OQ, then of course OP is also smaller to OQ. Am I right? So where is OP? So OP is here and OQ is here. So according to OP, OQ is the longest one. Am I right? So here we have OP and here we have OQ. So I'll explain it. Okay. So here we have OP. So here we have OP. Am I right? So according to OP, so according to this OP, OQ is so big. Am I right? So OP is so small and OQ is so big. See the line difference. So according to these two fingers, this is so small, but this when it comes to this OQ, it is stretching out. The two fingers are stretching out. Am I right? So here the centimeters are just this much, but when it comes to Q, it is just stretching out. Am I right? That means this is small and this is big. Okay. So if you want to measure with scale also, you can measure if you have doubt. So yeah. So here according to the scale. So according to the scale. So 1 second. So according to the scale, OP is 5.7. Okay, 5.7. According to OQ is, 1 second, I'm literally sorry guys, so I just made some measurement mistakes. Okay, so now let's measure it from starting. So now let's measure OP. So according to OP, it is 3.5. Yeah, exactly 3.6. Okay, but according to OQ, it is 4.7. It is way too big. Am I right? So then which is the biggest one? 3.7 is biggest number or 4.7 is biggest number? Of course 4.7 is the biggest number. That means we can just conclude that this is the biggest side. Am I right? That's why we just wrote this one. Okay. So for a single reason also, for a single letters and single values also, we have a deep explanation. If you know the deep explanation, no need to mug up it. Okay, so here since you guys know OP is smaller to OQ. Why? Because OP is here and which is smaller, and when it comes to OQ, it is so big. Okay, so if you take the measurements also, according to the measurements also, OQ is big and OP is small. Okay, so this is the simple reason. Alright, so since OP is smaller to OQ, then we can just conclude that OP is perpendicular XY. So what did I say in the starting? So in this video, in the starting of the video, I just told that if this OP is smallest, then if this side, that is OP side, is smallest, then the OP is perpendicular to XY. Okay, so I just told something to remember till the end of your life. Am I right? That is what this one. Okay, so that is OP is perpendicular XY. If you want to prove something is perpendicular, we are supposed to, according to this theorem, we are supposed to make this OP as smallest side. If you make this OP as smallest, then no need to think at all. We can just write it that it is perpendicular. Why? Because if this is perpendicular, then of course I am sure, no doubt, that it is perpendicular to XY, that is a tangent. So hence, now let's write, hence OP is the smallest side. Whether it is smallest line. Okay, so I am sorry guys for using the word side. Okay, so since I did the video that is triangles, in that full of we are supposed to use sides, am I right? So I just got confused. Don't use side in this circle lesson. We are supposed to use line. Okay, so OP is smallest line, is the smallest line. So since it is the smallest line, from the center to the tangent. Okay, so we just mentioned directly, we didn't just mention any values. Okay, so here OP is the smallest line, it is important, center is important, tangent is important. These are the main words. Okay, you are supposed to use these. So and line is also important. Okay, so almost everything is important. Okay, so I'll just explain this also. Hence OP is the smallest line. So this OP is the smallest line. I just concluded it. I just told you the reason. So since it is the smallest line, from the center means this is the center, that is O. Okay, so this according from the center to the tangent, that is XY, OP is the smallest line. Am I right? So in according to this circle, how many lines are there? So here one line and here one line. Am I right? So in these two lines, which is the longest line? OQ is the longest line, OP is the smallest line. Am I right? So according to this whole circle, OP is the smallest line. Am I right? So since it is the smallest line, we can just write OP is perpendicular to XY. So OP is perpendicular to XY. Hence proved. Okay, hence proved is really important. Okay, hence we proved. Am I right? So this was about the theorem 10.1. okay, so this is really an important theorem. So in the next video I am going to be doing theorem 10.2. that is also an important theorem. So most probably we have questions from theorem 10.1 and 10.2. okay, so we are supposed to learn that. Okay, so if you just know this diagram, then it is really easy to solve it. Okay, so I hope you guys understood this part and this part, that is OR is smaller to OQ. So this is OR which is smaller to OQ. Okay, just remember these two fingers. So OQ, we have OR right over here which is smallest, and OQ that is biggest. Why? Because the two fingers are stretching. Am I right? So here it is like this, but if you want to see OQ, then the fingers are moving like this. Am I right? So then it is the longest part. So we are supposed to write this also, OP is equal to OR. Okay, it is also important. So OP is equal to OR since it is a radius. Okay, so these both are radius. Okay, according in this circle, no, these both are radius and this is a tangent. Okay, you are supposed to know every single line. For what purpose we have this line? Okay, and the one more thing, we are supposed to use the word line in this circle chapter. Okay, so because a circle is full of lines, of course, those things and all. So yeah, this was about theorem 10.1. so finally we just proved it.
Thank you guys for watching this video. Please like this video, share it to your friends and subscribe to our YouTube channel. If you have any doubt, you can comment me in the comment section. You can find my videos in the playlist. You can also find my sister Tina's